In this video, we will look at the remainder theorem by first stating the theorem itself and also stating a special case of the theorem called the factor theorem. And then we are going to look at three techniques of long division of polynomials, and we focus entirely on the case when the divisor is a linear polynomial. And we carry out three methods whereby you can effect the task of long division. And at the end of the video, we will look at some examples. We'll start by first stating the remainder theorem. And so we let p of x be a polynomial of degree n, where n is greater or equal to 0, and we let ax plus b be a polynomial of degree 1, sometimes called a linear polynomial or a linear factor. Now, the theorem states that when you divide p of x by ax plus b, you will get, of course, a quotient and a remainder. And the remainder, in this case, is going to equal to p of minus b over a. In other words, if you want to get hold of the remainder without actually dividing p of x by the linear polynomial ax plus b, all you have to do is to substitute the number minus b over a for x in the expression of p of x. Now to the special case of the remainder theorem, which is sometimes called the factor theorem. This is the case when the remainder is equal to 0. When the remainder is equal to 0, what we are talking about here then is that the polynomial ax plus b is going to be a factor of the polynomial p of x. And the theorem quite simply states that ax plus b is a factor of p of x if and only if the remainder is equal to 0, or if you like, if and only if the result of substituting minus b over a for x into p of x is equal to 0. Okay. Now, before we look at questions involving either the remainder theorem or the factor theorem, we will say a few things about long division of polynomials, because the technique usually figures prominently in many of the questions involving the remainder or the factor theorem. So what do we mean by division of polynomials? What we mean is, if we start with a polynomial p of x, and another polynomial d of x, then to divide p of x by d of x means to be able to find a polynomial q of x, which is usually called the quotient, and another polynomial r of x, so that p of x is going to equal to d of x times q of x plus r of x. D of x is the divisor, and q of x is called the quotient of division, and r of x is the remainder. And the main point here is that the degree of the remainder is less than the degree of the divisor. A degree of a polynomial means the power of the leading term in the polynomial. We're now going to look at an example to illustrate how long division of polynomials is performed. We will look at the following example in which p of x is equal to x cubed plus 3x squared plus 5x plus 3, and d of x is equal to x plus 2. And the division process is laid out as follows. As you can see, here's b of x there's b of x there. And q of x is x plus 2, which is there. Now we'll start by constructing q of x in this area here. The first term in q of x is going to be a power of x that, when multiplied by x plus 2, will give x cubed. And that power is obviously x squared. So x squared times x is x cubed, times 2 is 2x squared. And now if you subtract, we will get x squared. Just bring the rest of the terms down to get x squared plus 5x plus 3. And now we look for a power of x when multiplied by x plus 2 will give x squared. And that power is obviously x. And we'll have x squared here plus twice x. And we subtract. And we'll now get 3x plus 3. And finally, we have to multiply by a number. When we multiply by x plus 2, will give us 3x, and that number is obviously going to be 3. So we'll have 3x plus 6. And if you subtract, you'll get minus 3, and that minus 3 is the remainder. And therefore, p of x, which is 3x cubed plus x cubed plus 3x squared plus 5x plus 3 is going to equal to the divisor multiplied by the quotient plus the remainder, which is minus 3. The same result can be obtained by what is called synthetic long division. And this is how synthetic long division is performed. You start by setting x plus 2 equal to 0, which means x is equal to minus 2. And then we just look at the coefficients of the terms in p of x, and the coefficients of the terms in p of x are 1, which is the coefficient of x cubed, 3, the coefficient of x squared, 5, the coefficient of x, and 3, the constant term. And then if you just place minus 2 about here, okay, and then just draw a horizontal line under all the coefficients of the polynomial p of x. And the first thing you do is you look at the first coefficient, 1, which is the coefficient of x cubed, and just put that down as 1 here, and then you just multiply that by minus 2, that minus 2 here, put this minus 2 there, and the result is minus 2, of course. And then 3 plus minus 2 is 1, and then you multiply this one by minus 2 to obtain another minus 2, and then you add 5 minus 2 is 3, and then you multiply this by minus 2 to get minus 6. Minus 2 times 3 is minus 6, and if you add, you will get minus 3. Now what this means is that the quotient then is a degree 2 polynomial whose coefficients are 1, 1, and 3, and that the remainder is minus 3, and there is the answer there. Q of x is then x squared plus x plus 3, and the remainder r of x is equal to minus 3, and therefore p of x, which is x cubed plus 3x squared plus 5x plus 3 is as before, x plus 2, that's d of x, times quotient x squared plus x plus 3 plus the remainder, which is minus 3, which you can see quite simply is the same as the result obtained using the procedure above. The third method to complete long division is by inspection, and this method applied to the same example goes as follows. Okay, so I have x cubed plus 3x squared plus 5x plus 3. This is going to equal to the divisor and multiplied by the quotient plus the remainder. And I'll try to figure out what the quotient is by inspection. Now, because p of x is equal to x plus 2 times the quotient, the first term in the quotient must be x squared. Why is that? Because the only way to get x cubed here is by multiplying x by x squared. So therefore that first term cannot be anything except x squared. Now if I shift my attention to the term in x squared in p of x, I will need to find a term in x so that when I multiply the two brackets I get 3x squared. I have already got 2x squared from here. 2 times x squared is 2x squared, so I need another x squared to make up 3x squared, which means the second term must be x, because that's the only way I can get 3x squared by multiplying the two brackets out. And finally, I'll shift my attention to the term on the left hand side, the term in x on the left hand side, which is 5x. Now you can see up to here I've already got 2x, so I need another 3x, and this can only be done if I have 3 as a constant term of the quotient. Okay, and finally, to decide what the remainder is to work out what the constant term is when I multiply the two brackets out. And you can see quite clearly when you multiply the two brackets out, the constant term is 6. 2 times 3, which is 6, but I'll have 3 on the left hand side, so there is nothing I can do other than subtracting 3. And that is the end of the procedure, and you can see I still got the same result as the result before. And this, so therefore you've got these 3 methods whereby you can find the result of long division, i.e. find the quotient and remainder when you carry out long division.